Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Student, in our previous video we discussed about the types of relations and few basic problems on relations. Now in this video student, we will discuss some important problems on relations of second PUC. Relations of second PUC. So student, before I start the problems, if you are new to our channel, so don't forget to subscribe and share our videos and like our videos so others can be benefited. So student, let us start the problems of relations. The first problem of today's video is, student, we know basically relations we will do first reflexive, symmetric and transitive. Basically these three types we will discuss in state board. So first we will take the problem based on these things. So determine whether the relation R, this R is a relation R in the set capital N. Student, here capital N represents the set of all natural numbers. You know, in number systems, capital N represents the natural numbers. So here capital N is set of all natural numbers. Defined as R is equals to x comma y such that y is equals to x plus 5 and x is strictly less than 4 is reflexive, comma symmetric, comma transitive, or not. Then very simple problem, and he is asking us to check whether this relation in set of all natural number is a reflexive, symmetric, transitive or not. So let us discuss one by one. First, solution. Given set is equals to set of all natural number. That means natural numbers. Okay, this is our set. And what is the relation? Relation R is equals to x comma y such that y is equals to x plus 5, where there is a condition for x, that is x must be strictly less than 4. X cannot be 4, but it is less than 4 in the natural numbers. We know less than 4 in the natural number is 1, 2, 3. Only 3 numbers for x. First one is reflexive. So student, we know in reflexive, each and every element of this set must have reflection. If any one element doesn't have reflection, it means the element must be related to itself. If it is not related to itself, then we will declare that it is not reflexive. So, okay, here I will write the relation. Before I go to the reflexive, let me write the relation here. If I put x is equals to 1, y equals how much? 1 plus 5, it is 6. If I put x is equals to 2 here, if I put x is equals to 2, I will get 2 plus 5 is 7. If I put x is equals to 3 here, 3 plus 5 is 8. Student, because he said x must be less than 4, so x can be then 1, 2, 3. So if I take x is 1, then y I got 6, because 1 plus 5 is 6. If I put x is equals to 2, I will get 2 plus 5 is 7. Then next, if I put x is equal to 3, 3 plus 5 is 8 is y. Okay. Student, this is the relation I should check. What exactly we check in reflexive? If A is an element, then we will check whether this element A is related to again A or not. For all A belongs to the set. A belongs to set, and here set is natural number. Set is natural number. Okay. So like that I will take 1. This implies A comma A belongs to 1. A comma A belongs to R. Instead of this, we can write like this also. That is, A is related to A, then we will write it belongs to. Okay, let me take some element from this. If suppose if I prefer 1, choice is mine, anything we can take. But if I accept 1 comma 1 is not there, so that means it does not belongs to R. Because I have 1 comma 6 and 2 comma 7, 3 comma 8. So it means no element is related to itself in this relation. So it does not belong to R. Therefore, R is not reflexive. Next, second one. Symmetric. The definition of symmetric says that if we have element A and it is related to B, then we will check whether B is related to A or not. First for all, A comma B belongs to N. That is set. These two elements from our set. So let me check with this. That is, student, if I take 1 and 6, okay, 1 comma 6 belongs to R, but student 6 comma 1 does not belongs to R. Okay. A related to B, but we don't have B related to A. Therefore, it is not symmetric. Therefore, R is not symmetric. Third, transitive. Transitive relation. Student, in transitive, what exactly we'll do is, we will check A related to B. We will take A is related to B, and we will take B is related to some other element C. B is related to some other element C. Then we will check whether A related to C exists or not. We will check A related to C exists or not. If this is exists, then it is transitive. Otherwise, it is not transitive. And student, in transitive, we will take one more case. That is a special case in transitive. If suppose the second statement, if this itself is missing, first statement is there, but in our relation there is no element which starts from B again, then we will declare those relations are transitive by contradiction. That is, contradictorily it is transitive, we will declare. So student, here if I take any element, for example, I take 2 comma 7. 2 comma 7 belongs to R, okay, first case, but there is no element which starts from 7 here. It has 3 elements, but there is no element which is starting from 7. So therefore, here there is no element, which starts from 7, or there is no element which is start from 7. Therefore R is contradictorily transitive. Student, why it is contradictorily transitive? Because second statement is missing. First one is there, but second one is missing. So we cannot check the third one. When we are unable to check the third one, then we don't have any other way, but it is contradictory. It is not purely transitive. That's why I written here contradictory, it is transitive. Same thing. In this problem also we should determine it is reflexive, symmetric, transitive or not. So just I'll write the set. Determine the relation R in set A equals 1, 2, 3, 4, 5, 6. This is the set defined as R equals x, y such that y is divisible by x. The relation defined here is y is divisible by x, is reflexive, symmetric, transitive. So we should check again all three relations here, but this time set is clearly defined here. What is our set? 1, 2, 3, 4, 5, 6. There are 6 elements in our set. The relation is y divided by x. Solution. First, given set is A, 1, 2, 3, 4, 5, 6. And relation is x, y such that y divided by x. Y is divisible by x. Of course, this x and y belongs to this set. X and y must be the elements of the given set. First one is reflexive. Student, reflexive, as I said, A related to A, for all A belongs to set A here. Set is A here. Now, every element is divisible by itself, isn't it? Every element is divisible by itself. So 1 divided by 1, 2 divided by 2, 3 divided by 3, 4 divided by 4, 5 divided by 5, 6 divided by 6. So it means every element is related to itself. Therefore, 1, 1 belongs to R here. Because every element is getting divisible by itself, and so on. And so on. Therefore, R is reflexive, Next, symmetric. Student, symmetric, A related to B, which implies B related to A for all A comma B belongs to our set A. So first I should check A should be A related to B. It means B is divisible by A. Then I should check A divisible by B is there or not. So student, A is divisible by 2 means Y should come as the first, then X. Y should come as the first. Sorry, X comma Y, no. So it is here. This is X, this is Y. 1 comma 2 means X is 1, Y is 2. That means 2 divided by 1. 2 divided by 1 is possible. This belongs to R. 2 divided by 1 is possible, and that means 2 divided by 1 answer is 2. This present in our set A. So this belongs to R. But 2 comma 1 student, this does not belongs to R. The reason is 1 divided by 2. This is Y. This one is Y, second term. 1 divided by 2 is not possible here. It implies 1 by 2 is half. This half is not the element of set. It does not belongs to it. Therefore, R is not symmetric. R is not symmetric. Third, transitive. Student, in transitive we need 3 elements. So the definition of transitive is, if I have A related to B, comma, and B related to C, then it implies A should be related to C. That is, A is having relation with C. For all A comma B comma C belongs to set A. These 3 A, B, C are elements of set A. So that means, student, I will take like this. Okay. 2 comma 1 belongs to R, and 2 comma 4. It is 4 divided by 2. 4 divided by 2. This is also belongs to R. Then definitely, student, 1 comma 4 is also possible. 4 divided by 1 is possible. Then 1 comma 4 is also belongs to R. Because Y is this, Y divided by X. 4 by 1 is 4. Therefore, R is transitive. R is transitive here. Expansion are given here. So how can we write 1 comma 2? It is 2 by 1. And the set is, I will just write set here. Set A is a set, and what is this set declares that? Set A. Set A declares that it is human beings in a town at a particular time. Again, at a particular time. So here set is what? Human beings in a town at particular time. given by the relation R equals x comma y such that x and y are the two persons here. X and y work at the same place. So student, this is the relation. X and y work at the same place. And this we should check whether it is reflexive, symmetric and transitive or not. So solution, given set A equals human beings in a town, then R equals x comma y such that x and y work at the same place. So student, here two persons are working at same place, that we should check. Student, first reflexive will take. Student, in reflexive we will take x related to x here. Student, x is number of a person is working in its own place. Yes, of course, he is available in the office. The person is going to office, he is having his office, then obviously he is working in his office. So yes, it is possible, because in reflexive we cannot take another person. We should take only one person, then we will relate with that itself, the person itself. So yes, it is possible. That means x comma x belongs to R. Therefore, you can write like this: x comma x belongs to R means x and himself. X and y I cannot write, or x only I should write. X and x means here himself. Himself work at the same place. Student, here in this kind of statement problems, we cannot change any statement. As he has given in the question, same thing we should write. Same thing we should write. Therefore, R is reflexive. R is reflexive here. Next. Symmetric. This is very easy if he has given this kind of statement problem. Student, he himself has declared that, he has declared clearly that x and y are two persons working at the same place. First, we will take the same statement itself as the first statement in symmetric. What is symmetric says? If x related to y, then we should check y related to x. For all x comma y belongs to set A. So that is the first statement, x and y work at the same place. X and y working at the same place means this can be written as x comma y belongs to R. So student, now first thing I should, in the second statement of symmetric, I should just change the positions of these two persons. Now y and x, because symmetry, reverse I should check. Okay, x is working in place of y. Now I should check whether y is working in place of x or not. So y and x obviously work at the same place. That means y comma x belongs to R. So if these two cases belongs to R means therefore R is symmetric. R is a symmetric relation. Third, transitive. Student, in transitive, we take x related to y and y related to z. We will take z is a person. This implies x related to z. If x and y working in the same place and y and z also working in the same place, then we should check x and z are working in the same place or not. What are these x, y, z? X comma y comma z belongs to our set. Student, here first statement, x and y work, same statement, whatever he has given in the relation, same statement I should write in transitive as the first condition. X and y work at the same place. This gives x comma y belongs to R. It is present in our relation. Second statement, y and z. Z is another person here. Y and z work at the same place. These two persons are working in the same place. That means y comma z is also belongs to R. Okay, if these two things are belongs to R, now I should check x and z is working or not. Obviously, student, say x is working in place of y, y is working in place of z. Then definitely means these three persons are working in same office. So obviously x and z is also work at the same place. Then x and z work at the same place, which implies x comma z belongs to R. If this is belongs to R, then we will declare that therefore R is transitive. Again, in this question also, we should check reflexive, symmetric and transitive relation, and this is also related to human beings. So our set is A, and what is A? Human beings. In a town. In a town at a particular time. The relation is x comma y such that, mentioned here, such that x is y for y. X is a y for y. This kind of many relations we can relate here. X and y are the two persons. These two are two persons. Then there are many relations between these two persons. Here he has given an example as wife. We can take it as husband. We can take it as father. We can take it as brother, sister, grandfather, etc. etc. Many examples we can take here. But let us discuss first with this wife. But exactly similar to this relation will change. Okay, we'll take solution from here itself. Solution. Okay. First one is reflexive. Okay, student, reflexive. What exactly we'll do in this? We will take one element and we relate with that element itself. But what is the relation here? We get it is y. Now, student, in human beings, it's quite common. Everyone knows the fact that x cannot be wife of x, isn't it? The person cannot be wife of herself or himself. So we can, okay, first definitions are right. What is the definition of reflexive? X should be related to x. If this is there, then we can write x comma x belongs to R for all x belongs to our set. Now here, student, since it is a statement problem again, as I said in the previous problem, any statement is given, then we should involve that statement in our answer. So what is the statement here? X is a wife, x is not a wife of x. Student, here, since it is reflexive, I cannot write x is wife of x. It is not possible in general. So it is a human beings we are discussing. So x, I should write that x is not a wife of y, or x cannot be wife of x. So if it is not present here, then you will declare that x comma x does not belongs to R here, because the statement is just wife, but here you have taken not a wife. Therefore, R is not reflexive. R is not reflexive. Next, second, symmetric. Student, first statement, okay, definition of symmetric is if x is related to y, then we should check whether reverse is also possible or not. Reverse means y is related to x is there or not. Or these two are the elements of our set. So first statement, he himself has given the first statement, that is x is wife of y, which implies x comma y. Okay, this belongs to R. Okay, no doubt, x comma y belongs to R. X is wife of y. Now what is if I reverse this statement? Then the previous statement will get completely vanished. Now, second statement. See, earlier in the previous statement, I accepted that x is wife of y. Now, in the second statement, I cannot say that again y is also wife of x. So, I will write y cannot be a wife of x, isn't it? Because previously I accepted that x is wife of y. Now, here I cannot again declare y is wife of x. It is a meaningless statement. Okay. If I write like that, the complete gender will change. So I should write the second statement as y cannot be a wife of x. What does it mean then? It says that y comma x does not belongs to R. Y comma x does not belongs to R. Therefore, R is not symmetric. Now third is transitive. Transitive. In transitive, we need three persons. Let me introduce the three persons as a definition. X related to y, and y related to z. Z is the third person here. If these two things are there, I should check x and z has relation or not. What are these three elements? X comma y comma z belongs to set A. These are the members of this human being. Okay, students. Again, the first statement is as it is from the relation x is wife of y. The first statement as it is, no changes. That means x comma y belongs to R. Okay, first statement is acceptable. Okay, yes, student. Second statement, just here, second statement. Y, I cannot write y is z, wife of z, because in this first statement, here, y, its gender is male gender. But if I write y is again wife of z in the second statement, if suppose if I write y is wife of z, then here I am changing the gender of y. Earlier in the previous statement I accepted this is a male gender. Now if I accept, if I write that y is wife of z, suppose if I write suppose like this, then here y will be a female gender. Isn't it? This is totally not possible. Very impossible it is, because in the previous statement I am taking it is a male and here it is female. So I cannot change the gender of this. So second statement I cannot accept. Y is wife of z. Cannot be accept. Cannot be accept. A student here, cannot be accept means it doesn't mean that it does not belongs to. It does not belongs to. But here it is not present. Second statement is not at all exist here. Second statement is not exist, because when I can check the transitive, first I should check the first statement, that is x should be related to y and y must be related to z. If these two things are exist, x must be related to y and y must be related to z. If these two things are purely exist, then I should check for the third statement. If any one of these is not exist, no need to check the third one. And here since second statement itself is not exist, cannot acceptable, that is exist. So I will declare that it is contradictorily transitive. It means what? If suppose this is possible, if y is wife of z, if this is possible, then I can say something. But here since it is not there, since second statement is not there, therefore I will declare that R is contradictorily transitive. R is contradictorily transitive, because there is no second statement here, so I cannot check the third one whether it will be belongs to or not. I hope you people understood this problem. Even similar to this, in set of all human beings, whether it is in a town or whatever it is, this kind of many relations can be found. In your textbook has been one more problem like father of x is father of y. You can declare many relations like this. X is brother of y, x is son of y. Many examples you can take. But similar to this, if it is belongs to, then it is possible. If it is does not exist, then it is not acceptable. Like this. But exactly goes similar to this one. So I don't think I need to discuss much about this kind of general human beings relations. Now we'll directly come to the standard problem of relations. Standard problems of relations, that is numerical problems. Show that show that the relation R in the set capital R. Student, here this R is a relation, and here set capital R means set of all real numbers. Capital R means set of all real numbers here. R defined as R equals A comma B such that A less than or equals to B square is neither reflexive, symmetric, transitive. Student, here we should prove that this relation is neither a reflexive relation nor a transitive, nor symmetric nor transitive. So maybe for some numbers it may be possible, for some numbers, few numbers, but as I said in the previous classes that we should check for each and every element of a relation, every element of the relation as well as this set. Set is here real numbers, set of all real numbers, positive, negative, fraction, decimals, zero, everything we should check. So that's why it is declared that show that. Somewhere it is possible, but wherever it is not possible, that we should declare, because always that gives an important for us. So it is first given set. What is set? Capital R. Capital R is real numbers. Set of all real numbers. Capital R is real numbers. Relation is what? Relation is equals to A and B are any two numbers. The relation between the two numbers is A is less than or equals to B square. This is the relation. For all A comma B belongs to real number. This R is real number. So first we will discuss reflexive. Student, it is not necessary that you should prove in order. First reflexive, then symmetric, next is last is transitive. You can write in your wish, according to your wish, but it's better you follow the procedure. The procedure says what? First is reflexive relation, then we discuss symmetric, then we discuss transitive. So reflexive comes first before symmetric, then symmetric comes before transitive. So it's better you follow this order: reflexive, symmetric, transitive. But it is not totally not wrong if you change the positions. So what is reflexive says? If A is the element, then this related to itself, which means A comma A belongs to R. Now let me take some number here. Okay, whatever number I will take for A, same thing I should accept for B also. Let A equals 2. Since it is in reflexive, I need only one element, then let me take B is also 2 here. B is also 2 because A must be related to A here. I cannot take some other number. Let me check whether I will get the answer 2 comma 2 or not. So 2 less than, I will write here itself. It implies 2 less than or equal to 2 square. That means 2 less than or equals to 4. Student, just be careful here. See, 2 is strictly less than or equals to 4. Okay, condition is satisfied. Obviously, there is no doubt that 2 is less than 4. Condition satisfied. But what exactly we need in reflexive? We need the input is 2 means then we will expect output also 2. In reflexive, whatever the input we will give, same output we should expect always. That is reflexive, reflection. If I am standing in front of the mirror, I should get my own reflection. If it is somebody's reflection, then it is not reflexive. See, that's what it's happened. 2 is standing in front of the mirror, but the reflection shows the person 4's. Reflection is showing, but it is different persons. So what we can declare here, that is 2 comma 2 does not belongs to R. Don't bother about that, sir. Condition satisfied here. Yes, condition obviously satisfied. There is a reflection, no doubt. But which person's reflection is not there? Person 2 reflection is not there here. That is, if 2 is there, is input, then output also should be 2 only. But here output we got 4. That's why I written 2 comma 2 does not belongs to R. Here 1 comma 1 may be possible. So if suppose instead of 2, if I would have taken 1, it may be possible. But other than 1, it is not possible. Even if it is not possible for 3, 4 other numbers. But any one example is enough. Therefore, R is not reflexive. Okay. Second one. Symmetric. Okay, students, symmetric. What is it says? It says that A related to B. If the first number is related to second number, then we should check. Then there should be second number is related to first number. Where these two numbers are the elements of our set. Here set is set of all real numbers. So student, here let A equals 1. Let me take A equals 1 and B equals 2. Here I cannot give same number. I can give different numbers. Okay, let me check with this. 1 less than or equal to 2 square. Because see, A less than or equal to B square, which implies 1 less than or equal to 4. Yes. Student, here condition is accepted means we can accept the answer. Condition satisfied, so answer is correct. That means 1 comma 2 belongs to R, because for these two values condition satisfied. Okay, I will write here A less than or equals to B square. Next, let me change the position, because what is the second statement in symmetric? Second should be related to first. If I change the position, then it is B less than or equal to A square. Let us check whether it is possible or not. B is how much? 2 less than or equal to 1 square. So what is 1 square? 2 is 2 only. Less than or equal to 1 square is 1. Student, this is not possible. 2 cannot be less than or equal to 1. This declares that 2 comma 1 does not belongs to R. Okay, first statement is satisfied, but second is not belongs to. Therefore, R is not symmetric. Now let's take the third one. Third is what? Transitive. Student, in transitive we need 3 statements. The first one is first element should be related to second element, and second element must be related to the third element. Their third element is C. This implies first element related to third or not. We should check. And here this C is independent. It can be again A or again B, anything. For all A, B, C belongs to set of all real numbers. The student here, let A equals 3, B equals 2, C equals 3 by 2 or 1.5. 1.5 I will take. Student, you can take any numbers. It is not necessary that only for these two numbers it will be like this. No, there are infinite numbers which gives this kind of results. Just take one example here. If you want, you can change the numbers, but make sure that it should give this kind of relations, because here we should prove that it is not symmetric reflexive, it is transitive. So like that, for even transitive, I have taken A equals 3, B equals 2, C equals 1.5, that is 3 by 2 in fractions. You can take even negative also, you can take, because it is real numbers. Here you can take all three numbers are fractions. Choice is yours, but I have taken these numbers because it is easy to explain you, and you can, according to this, you can change the numbers if you want. Otherwise, you can carry and continue with same numbers. Okay. So the first statement here is A less than or equals to B square, which implies 3. Student, A is 3 less than or equal to B. B is 2 square. Sorry student, there is no space here. Okay, erase this. Okay, student. Transitive I will prove here. So what are the values? A equals 3, B equals 2, C equals 1.5. First statement, A less than or equals to B square, which implies A is how much? A is 3. 3 is less than or equals to what? 2 square. Okay. Which implies 3 is less than or equal to 2 square is 4. So here condition satisfied. It's enough to tell that it is belongs to, which implies 3, 4 belongs to R, that is relation. Next, B is less than or equal to C square. That means second and third element we are checking. That is second statement. Second and third. This implies B is how much? B is 2 less than or equals to 1.5 whole square. 1.5 whole square. This implies, student, this 2 as it is, less than or equal to 1.5 whole square. What is 1.5 whole square? It is 2.25. 1.5 whole square is 2.25. That means 2, 1.5 is belongs to R. Student, these two statements, first and second, belongs to R. Now let us check the third one. What is the third one? Says first element should be related to third element. That is A less than or equal to C square. That means this implies A is how much? Now A is 3 here. 3 less than or equals to 1.5 whole square. Student, be careful here. This gives 3 is less than or equal to 1.5 whole square is 2.25. See student, earlier it is satisfied because there was 2 here. Now this is 3. 3 cannot be less than or equal to 3 cannot be less than or equal to 2.25. That means 3 comma 1.5 does not belongs to R. It does not belongs to R. So therefore R is not transitive. R is not transitive. Hence it is proved. Next problem is similar to the previous problem. That is, this time we should check whether the relation are in set of all real numbers. Check whether the relation in set of all real numbers. This capital R represents our set. It is set of all real numbers defined by R equals A comma B such that A is less than or equals to B cube. In the previous problem we had taken B square, now it is B cube. For all A comma B belongs to real number. Is reflexive, symmetric and transitive. Is reflexive, symmetric and transitive. Student, here we should check which one it is. And for all real numbers, you can give any number, fractions, decimals and even negative numbers. So student, in this problem also, just to explain you people, I will take some direct numbers, some easy positive numbers, but don't think that only these are the correct values. For other values it may give different answer. No, there are infinite steps for this, but I prefer easiest one, so you people can easily understand. So student, let us start. What is the set here? Set is equals to real number. R is here real numbers. Real numbers. What is the relation? Relation is A comma B such that A is less than or equal to B cube. What are these A and B? These A and B are the elements of our set. And yes, set is real numbers. Okay. Students, let us start with reflexive. Student, first definition. A related to A, then it means A comma A belongs to R. What is this A? Of course, for all A belongs to our set. Set is real number. This is the relation, but this is real number, our set. Okay, student, here again in reflexive, if I take A is 1 and B is 1, 100% it satisfies, because 1 is because here there are two operations, less than as well as equal. One may not be less than 1, but 1 is always equals to 1. Whenever this kind of two operations are given, if any one is satisfied, it is enough. You will declare that it is satisfied. But let us check how about the other values. Other than 1, let us check. If, again, I will start with the 2. If A equals 2, then obviously I should take B also 2 only. B equals 2. What does it says? That is, A should be less than or equals to A square here. Sorry, cube it is. Okay, I'll take. Since it is reflexive, I cannot take other element. So it is A cube only. A less than or equal to A cube. But remember, in reflexive always, whatever the input we will give, we will always expect the same output. No changes in the output in reflexive. So that implies 2 less than or equal to 2 cube gives 2 less than or equal to what is 2 cube? 2 cube is 8. That means no doubt condition is 100% correct. 2 is 100% less than 8, no doubt. But what exactly we will expect in reflexive? Input is equals to output. That is not there. So I will declare that 2 comma 2 does not belongs to R. That means this 2 comma 2 is not belongs to this relation. Therefore, R is not reflexive. Second, symmetric. And the definition of symmetric, if A related to B, this gives B is also related to A, or all A belongs to set. So first, A less than or equal to B cube. Okay, sorry. Before I start any definition, let us give some numbers to this A and B. So let A equals 1 and B equals 2. Simple numbers. Let us not make so much complicated. So I prefer A equals 1, B equals 2. It is very simple numbers and easily we can understand this. So what is the first statement? First statement is A less than or equal to B cube, which gives 1 is less than or equal to 2 cube. This implies 1 is less than or equal to 2 cube. It is 8. Here in symmetric and transitive, if condition satisfied, that's enough. So this says that 1 comma 2 belongs to R. That's correct. Now let us change the position. Let us reverse it. If I reverse, then what do I get? B is less than or equal to A cube. This time we should check with this. Okay, let us reverse the value. B is how much? B is 2 here. 2 less than or equal to 1 cube. 1 cube. And we know 1 power anything is 1 only. It won't change. So 2 less than or equal to 1. It is highly impossible. 2 cannot be less than or equal to 1. Then this says that 2 comma 1 does not belongs to R. 2 comma 1 does not belongs to R. Therefore, R is not symmetric. R is not symmetric. Third, is transitive. What is transitive says? It says that first element related to second and second must be related to third. If these two things are satisfied, then let us check whether first is related to third or not. Obviously, these three are elements of our set. It is real numbers. First, let us give the numbers to A, B, C. Let. So, what is A? A equals, I will give 10, B equals 6, and C equals 2. Let us check with these numbers. Third, as I said in the first itself, there are many numbers you can give to this A, B, C, which satisfies the relation, or which satisfies the relation or the condition. Don't think that only these three numbers, these are the numbers, sir. No, there are many numbers. The purpose I have taken the direct numbers, positive numbers, is you can understand easily. Because if I take some fractions or some decimals, some negative numbers, students may get confused, especially when taking cubes or some relating numbers. So just to avoid those confusions, I have taken the direct numbers. Okay, student. First statement in transitive, A less than or equal to B cube. What does it implies? A is how much? 10. 10 less than or equal to B is 6 cube, which implies 10 less than or equal to 6 cube. 6 is 36, 6 cube is 216. 216. So condition is satisfied. 10 is less than 216. That implies 10 comma 6 belongs to R, belongs to our relation. Next, second statement, B less than or equal to C cube. This says that B is how much? 6 less than or equal to 6 is sorry, C is 2 cube. That gives 6 is less than or equal to 2 cube. 2 cube is how much? It is 8. Yes. 6 is always less than 8. 6 is less than 8. So condition satisfied. So we will write 6 comma 2 belongs to R. Okay. Now let us check the third statement. What is it says? First element should have relation with third or not. We should check whether A is having relation with C or not. Let us check. A is how much? A is 10. Less than or equal to C is 2. It has cube. 10 less than or equal to 2 cube is 8. Student, let's see here. 10 cannot be less than or equal to 8. 10 is greater than 8. So it is possible. This implies 10 comma 2 does not belongs to R. So final conclusion is, therefore R is not transitive. R is not transitive. Next problem is, show that the relation R in the set A equals 1 comma 2 comma 3 comma 4 comma 5 given by R equals A comma B such that mod A minus B is even number. For all A comma B belongs to set A is an equivalence relation. Student, here the word equivalence is used. Equivalence means studied in types of relation. Relation which is reflexive, symmetric and transitive. That particular relation is called as equivalence relation. If it is not satisfied any one of reflexive, symmetric, transitive, then it is not equivalence. If it satisfies all the three, reflexive, symmetric and transitive, easily we can declare those relations are equivalence. It means indirectly is telling us to prove that it is reflexive, symmetric and transitive. Solution. Set name is A and it has some element 2, 3, 4, 5. What is the relation here? Relation is A comma B such that mod A minus B is even. Even number. Student, even number, we know the numbers which are divisible by 2, all those numbers are even numbers, are the numbers which are multiple of 2, like 2, 4, 6, 8, all those are even numbers. In even numbers, 0 is also considered as an even number. 0 is considered as an even number, because if we take whole numbers, the next number of 0 is an odd number, and in number system we know one is even, other is odd, even, odd, even, odd, even, odd, it will come. So if 0, the next number of 0 is odd, then before odd is even number, obviously. So 0 is an even number, no doubt about it. So let us discuss one by one. First is reflexive. Student, we don't need to bother what answer we are getting, but the answer should be even. Answer should be here even. Reflexive says if A related to itself, that means A comma A belongs to R. A belongs to a set A. Any element I can take from this set. So in general I will take, student, and that is A minus A. Any element I can take from this. I have 5 elements, I can take any element. A minus A. Answer is 0. Answer is 0. It is an even number. Okay, mod is there. Okay, mod is also there. Mod means exact number, means there is no negatives. If at all any negative comes, I will avoid that negative. So mod 0 is 0. Therefore, A comma A belongs to R. Example, if you want, I will prefer 1. Example, if A equals 1, 1 minus 1, mod 1 minus 1, you can take any number for A. I prefer the first one. So that is 0, mod 0 is equal to 0. That means 1 comma 1 belongs to R, and so on. Therefore, R is reflexive, and so on here. 2 comma 2 also, 3 comma 3, 4 comma 4, 5 comma 5. For every number it gives 0 as the answer. Second, symmetric. And definition of symmetric is A must be related to B. That implies B related to A. For all A comma B belongs to set A. Any number I can take for A and B, but first A must be related to B. First element should be related to second. So look at what is there. Even number I want. Okay. So student, here I will take mod A minus B is even. that means if I take A equals 1, okay, first let A equals 1, B equals 3. Any number, as I said, student, see there are 5 elements in our set A. Anything we can take, but we should take only those numbers which gives it is symmetric, because we should prove that it is symmetric. So you can take 2, 4 here, or 1, 5, anything. Then mod of A minus B is equals to mod of 1 minus 3, that is equals to mod of minus 2. 1 minus 3 is minus 2. Student, if I remove mod, the answer is 2. It's a even number. 2 is a even number. So what does it mean? That implies 1 comma 3 belongs to R, belongs to our relation. Next, mod of B minus A. If I reverse this, that is mod 3 minus 1. So what is 3 minus 1? 3 minus 1 is 2. Mod 2 is 2. That means 3 comma 1 also belongs to R. 3 comma 1 is also belongs to R. Therefore, R is symmetric. Let us check the transitive. Third, transitive. What is this transitive says? A related to B and B related to C, which implies A is related to C. For all A comma B comma C belongs to set A. A, B, C are elements of set A. The first thing is, let me give the names, numbers to this. Let A equals 1, B equals 3, C equals 5. A, B, C are the 1, 2, 1, 3, 5. First statement, mod A minus B is equals to mod 1 minus 3, that is equals to mod of minus 2, which gives 2. As I already explained here. So just to be easy, I have taken the same numbers. So student, this gives 1 comma 3 belongs to R. Second statement is mod of B minus C is equal to mod B is 3 minus 5. C is 5. So mod of 3 minus 5 is mod of minus 2. So mod of minus 2 is 2. This gives 3 comma 5 belongs to R. Since these two statements belongs to R, now I should check whether one belongs to 5 or not. So the third statement, mod A minus C is equals to mod 1 minus 5 mod of minus 4. Mod of 1 minus 5 is mod of minus 4. Mod of minus 4, final answer is 4, which gives 1 comma 5 belongs to R. Student, since it is belongs to R, so what I can say that therefore R is transitive. Since it is reflexive, symmetric and transitive, I can declare that hence the relation R is an equivalence relation. See, it is reflexive, symmetric, and transitive. That's why it is an equivalence relation. That's it. So here in this problem, we should show that in set A equals x belongs to z. Yes, student, z is an integer. X is an integer. Sorry, z is an integer here. So x is also an integer, such that the values of this x is 0 less than or equal to x less than or equal to 12. The values of x is from 0 to 12, positive values. Given by r equals a comma b such that mod a minus b is multiple of 4 is an equivalence relation. Children, again, in this problem also, we should prove that this relation is an equivalence under this set. And in this set, we have elements 0 to 12. That is positive integers 0 to 12. Solution. Given A equals is a set x such that it is an integer. X belongs to an integer such that 0 less than or equal to x less than or equal to 12. And the relation is a comma b such that mod a minus b is multiple of 4. A minus b is a multiple of 4. So student, let us prove one by one. We should prove that it is reflexive, symmetric, and transitive. First, reflexive definition is very important. A related to A, it means A comma A belongs to R. For all A belongs to set A here. A is the set here. So student, as we said that 0 is multiple of each and every number. 0 is multiple of each and every number. 0 into anything is 0 only. Or any number into 0 is again 0. So 0 is multiple of each and every number. It means 0 is multiple of 4 also. So yeah, let me take some number for A. Let A equals, I can take any number from 0 to 12. It's my wish, I will take 2 this time. If you want, you can take any number and so on also, and so on. Then what happened? Mod of A minus A, that is equals to mod of 2 minus 2. Answer is 0. 0 is multiple, that means 2 comma 2 belongs to R. 0 is multiple of 4. Therefore, R is reflexive. Second, symmetric. Symmetric means A related to B implies B related to A. For all A comma B belongs to set A. A and B are any elements from 0 to 12. So what are the values of A? Let us take A equals 1 and b equals 9. A equals 1, b equals 9. You can take any other numbers also, choice is yours, but make sure that the final answer should get multiple of 4. That is, multiples of 4 is 4, 8, 12, 16, and 16 is not necessary here. 4, 8, 12. So first statement, mod of a minus b. What is mod of a minus b here? Mod of a minus b is mod of 1 minus 9. That gives mod of minus 8. Mod of minus 8 is 8. Student, obviously 8 is multiple of 4. So 4 times 2 times is 8. So this says 1 comma 9 belongs to R, belongs to our relation. Second statement, mod of b minus a is equals to, let us change the position. Now 9 minus 1, mod of 9 minus 1. So that is equals to mod of 8, and that's answer is 8. This implies 9 comma 1 is belongs to R. Therefore, R is symmetric. Now let us prove transitive. So let me erase this. So now transitive. What is transitive says? If suppose A related to B and B related to C, then that should be given as A should be related to C, isn't it? For all A comma B comma C belongs to set A. All these A, B, C are elements of set A. So first statement in transitive, mod of, okay, before I go to the statements, let me take the values of A, B, C are numbers. Let A equals any 3 numbers from 0 to plus 12. Here I will prefer 0, easy numbers, B is 4, C equals 8. Already the numbers which are taken, it is multiples of 4 only. But still, with this itself, let us check the condition. What is the relation he has given? The first statement is difference of A minus B, that is 2 number, is multiple of 4. That gives 0 minus 4. Mod of 0 minus 4, that is equals to mod of minus 4, it is plus 4. Yes, 4 into 1 is 4, so 4 is a multiple of 4. That gives 0 comma 4 belongs to our relation. Second statement is mod of B minus C is equals to mod 4 minus 8, that is equals to mod of 4, negative 4 it is, mod of 4 minus 8 is mod of negative 4. Then final answer is plus 4, which implies 4 comma 8 belongs to R. 4 comma 8 belongs to R. Since these two things are belongs to R, now I should check the third one, whether 0 and 8 is having a relation or not. If this 0 and 8 is also having relation, then it is transitive. Otherwise, it is not transitive. Third statement of transitive is A minus C. That is mod of A minus C is mod A is 0 minus 8. So mod of 0 minus 8 is mod of minus 8. So its final answer is 8, which implies 0 comma 8 is also belongs to R, because 8 is multiple of 4. Since all 3 belongs to R, so we can declare that therefore R is transitive. Since the relation is reflexive, symmetric and transitive, so we will write that hence R is equivalence. Hence R is an equivalence. Now again let us solve some statement problems. Concept remains same, reflexive, symmetric, transitive. Obviously there is no other topic in relation, but the problems are related to statement. Here we will not take any numbers, statement will take. And as I said in the previous problems, whenever a statement problem is given, the statement is very important for us. We will take the statement as it is and then we will check whether it belongs to or not. Okay. The next problem is, show that the relation R in a set, the relation R in a set A of points in a plane given by R equals, I will write here, a relation R equals capital P comma capital Q such that distance of the point P from the origin is same as the distance of the point Q from the origin. So this is the relation, and this relation which is proved is an equivalence relation. Again, equivalence means this relation. We should prove that it is reflexive, symmetric and transitive. So student, very easy statement it is. See, he is telling that there are some points in a plane. Let us take xy plane, some xy plane here. This is x and this is y plane. We know coordinate geometry. We studied in our basic classes. So what he is telling that the distance, okay, this is the origin. The distance of the point P is a point from the origin is same as the distance of the point Q from the origin. It means there are two distances which are same. Then let us take one circle. Just to explain you people, I am drawing this circle. This is a circle. Let me mark point P here, capital P, and there is one more point, capital Q here. What is telling, the distance of the point P from the origin is same as the distance of the point Q from the origin. Obviously, it's possible these two distances are same. We can call this as radius. R for radius here, isn't it? Radius is always equal. Even if I draw any number of lines here, all those are called as radius, and all those points from the origin are equal. So yes, obviously, no doubt, We can easily prove this. First, let me write set. Set is A here. What is A here? Set of points in a plane. Points in a plane. So plane can be any plane. It is XY plane. Okay, since it is a one plane, let me take the points in this way. This is P. This is Q. It is origin. Single plane. Node X and it is Y. XY plane in one single plane. Okay. Now, student relation is already given here, so we'll write directly come to the point that is reflexive. Student in reflexive, since the statement is important for me, I should write the complete statement in reflexive, symmetric as well as transitive. So statement, what is student? What is the statement in reflexive? In reflexive, I cannot take 2 points. So any one point I will hide here. Let us take point Q, I will hide. Then the distance from O to P is same as the distance from P to O, isn't it? This distance O to P is exactly same as P to O for me. So that I should write here. And reflexive means if A related to A, because definition is important, so I must write this, which implies A comma A belongs to R. Obviously, for all A belongs to set A. So this, that is distance of the point P from the origin is same as the distance of the point the distance of the point P from the origin is same as the distance of the point again P, because Q I cannot take, P from the origin. Origin, otherwise I can write like this, point O, that is point O here. O is origin from the point P, that is OP is exactly equal to PO. O to P is exactly equals to P to O. This implies P comma P belongs to R. Point P to P belongs to R. Therefore, R is reflexive. So next, symmetric. Student, see, this statement is very important. You should write this statement. So I will try to avoid writing the statement. So I will write symbols like this. Symmetric. What is symmetric? Symmetric is if A related to B, this implies B related to A for all A comma B. A and B are the 2 points in a plane. So this belongs to our plane set A. So student, this first point is OP, that is the distance of O to P, is equals to O to Q. O to Q. This is the first point. This implies P comma Q belongs to R. So how can I write the statement of this? First statement is as it is given in this relation, no changes. So according to the first statement, given statement, I can write OP is equals to OQ. Then if I change the positions of P and Q, if I take the reverse, so it is OQ is also equals to OP. OQ is exactly equals to OP. That means wherever first we have written P, now in the second statement I should write Q, and wherever Q is there I should write P. So that means, Q comma P is also belongs to R. Both are the radius. O to P is same as O to Q. Therefore, R is symmetric. Obviously, statements are very important. You must write the statement, but just to explain you people, I written like this. After writing the statement, it's better to read like this also. Next, for transitive, there is this. For transitive, student, the definition of transitive says A related to B and B related to C, which implies A related to C. Obviously, ABC belongs to set A. Now, student, the first statement in transitive is same as statement given in the relation. The given relation statement in relation is OP is equals to OQ. That means capital P comma Q belongs to R. And student, here C is another point. The point name is, let us take R. R is another point here, and its distance from O to R. So again, this is O to R is also radius, O to P is radius, O to Q is also radius. That means all these distances are equal with respect to the origin. So the second statement is OQ is equals to OR. Instead of P, I will discuss only about OQ and OR. This statement says that Q comma R belongs to our relation. The third statement is OP is equals to OR. That means P comma R belongs to relation, because all these things are radius. So always in a circle, radius are always equal. So that's why I directly taken it is OP is equal to OR. Means point P comma R belongs to relation. Therefore, R is transitive, hence it is an equivalence relation. Hence it is an equivalence relation. Tenth problem, last. Okay. Let L, it is a capital L, will be the set of all lines in xy plane, has specified the name of the plane also, xy plane, and are with the relation or be the relation in L given by R equals L1 comma L2. L1 and L2 are two lines here, such that line L1 is parallel to line L2. Full stop. Show that R is equivalence relation, so that R is an equivalence relation. Also find the set of all lines related to the line y is equals to 2x plus 4. Y is equal to 2x plus 4 is a line. We should find the lines which are parallel to this, set of all lines which are parallel to this line. But before this, what we should prove? We should prove that this relation, that is line L1 is parallel to line L2, is an equivalence relation that we should prove. That means first here we should prove reflexive, symmetric and transitive. And here, what is this L? L is set of all lines present in xy plane. Again, I will draw the diagram. Let us take, this is x-axis and this is y-axis. These are the planes. Let me take, this is first line L1, this is second line L2, L3, L4, like that, dot, 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 dot. Many lines are there now. Solution. Set is L, that is equals to all lines in xy plane. All the lines in xy plane. The relation is L1 comma L2, capital L1 comma capital L2, such that L1 is parallel to L2. Students, this is the symbol we use for parallel. Two lines and LE power represents parallel. So let us start proving one by one. First is reflexive. First is a reflexive. What is reflexive says here? If A related to A, that is A related to A means A comma A belongs to R. And students, when we discussed about parallel lines, we will tell one statement from the lower classes that we studied, that is every line is parallel to itself, isn't it? This statement is very much familiar to us from our lower classes. So here, if I take line L1 is always parallel to itself. If there is no other line, then what we can do? We can declare that it is parallel to itself. That is, line L1 is parallel to itself. That says that L1 comma L1 belongs to R. Every line is parallel to itself, so line L1 is parallel to itself. That is L1 comma L1 belongs to R. With this, therefore, R is reflexive. Second, symmetric. Student, in symmetric, if A related to B, then B must be related to A. For all A comma B belongs to a capital L. L is the set here. Student, here in the statement problem, he himself has given the first statement. L1 is parallel to L2. That means L1 comma L2 belongs to R. As you can see in the graph, L1 is parallel to L2, obviously. Now, student, if I start from the top in a reverse direction, I can read that line L2 is parallel to L1, isn't it? Now, line L2 is parallel to L1. That gives L2 comma L1 belongs to R. Belongs to R. Therefore, R is symmetric. Now, transitive. Transitive. In transitive, we need three things. That is A related to B and B related to C. If these two things satisfied, then we should check A is related to C. What are these? A, B, C. A, B, C are the elements of our set. That is a L. So the first thing here is L1 is parallel to line L2. L1 is parallel to L2. That means line L1 comma L2 belongs to R. Now, second statement. I read this. Second statement. Student, here you can see that L1 is parallel to L2 is over. Now L2 is parallel to L3 also. Because L2 is parallel to L3. So line L2 is parallel to line 3, that is L3. That means L2 comma L3 belongs to R. Now at last, if I hide this line L2, if I hide this line L2, yes, if this line L2 is hide, then we can declare that L1 is parallel to L3. Here L1 is parallel to L3. If I remove this line, I easily say that L1 is parallel to L3. Yes, there is a relation between the first line and third line. That is L1 is parallel to L3. That gives L1 comma L3 belongs to R. Therefore, R is transitive. If it is since it is reflexive, symmetric, and it is transitive, so I can declare that it is an equivalence relation. Hence, R is an equivalence relation. R is an equivalence relation. This is one part of the problem. Now, in the second part, he said we should find the number of lines which are parallel to the line y is equals to 2x plus 4. Student, if I compare this, then I can easily write this as y is equals to mx plus c. See, he has given one line. Let us consider this itself is a line. This itself is a line whose intercept is 4. C equals 4. The intercept is 4. C is 4. What is the slope? M is 2. Right here. Slope M is 2. Student, if I compare this line and this line, this is a standard equation of line. This was studied in first QC and we derived the derivation. Compare these two things. Slope is 2, that is M is the slope, M represents slope. C equals 4. C is an intercept. Now student is asking us to write the equation of lines which are parallel to this line. And we know the concepts of parallel lines. The concept of parallel line is slopes are equal. If the slopes are equal, then we can call those lines are parallel lines. So student, for any line here, if it is parallel to this, slope remains same. The lines which are parallel to y is equals to 2x plus 4 is y is equals to 2x. This must be there. Slope must be 2 only. But what is the intercept? So the intercept is the only thing which is always changing here. Intercept is the only thing which is always changing. See, it intercepts at this particular point. This line intercepts at this particular point. And there is, if I draw another line, it intercepts at this particular point. For every line, the intercept is changing. So that is, for intercept, I will keep C itself because I don't know how many lines I will draw and how many lines are there. But this C is a real number where C belongs to real number. The value of C changes in this equation. As the value of C changes in this equation, like that much equation of lines we are getting. And obviously there are infinite lines, I can call it as. Because it is a plane, I don't know how many lines are there in a plane, isn't it? So there are infinite lines here, and all those equation of lines depends on the value of C. That's why I written C is real number here. So students, this is the final answer. And student, I hope you people understood the problems related to relations. Student, if you have any doubt in this topic, you can put your doubts in comment box. And to be helpful to other students, so you people can also help to other students, your friends, your classmates, by sharing our videos to others. And like our videos, don't forget to subscribe our channel. Thank you, students.